All right, section 1.2, number 10. All right, 9z minus 5 minus 4z equals negative 5. Okay, make sure when I write down the problems, I'm writing the correct problem down, because that would be a waste if I'm writing it down incorrectly. Absolutely, that is your first step. So what do you get when you combine your like terms? Nice. So a negative 4 or a minus 4 are the exact same. So you have 5z minus 5 equals negative 5. Perfect. Good call. Right. Nice work. Add the 5 to both sides to get rid of that 5 to further isolate the z. So negative 5 and positive 5 is 0. 5z equals 0. Well, you're absolutely correct. Yes. So to follow through with the steps, even though you know what the answer is going to be, to follow through with the steps to get rid of this, to isolate the z, you need to divide it by 5. So you need to divide both sides by 5. And just like you said, 0 divided by 5 is in fact 0. Yeah, is that a true statement? Does negative 5 equal negative 5? Yeah, so you just checked the problem. Well, you checked it in your head, but yes, that's it. So we go 9 times 0. That's a 0. Minus 5 minus 4 times 0 equals negative 5. You did these in your head. 9 times 0 is 0. Minus 5, 4 times 0 is 0, equals negative 5. Negative 5 equals negative 5. That's a true statement. So x does in fact equal 0. We just checked it by plugging it back in. Nice work. Now we're going to add an extra step and see how that goes. So number 11, 3 times the quantity z plus 7 equals 21. Now let's see if you remember what your first step is with a problem that looks like this. No. So no, I like your thinking because you're trying to figure out, okay, there's a 3 there, and what do I do with that 3? Let me tell you what the 3 is doing. So that 3 is multiplying everything inside of this parentheses. So it's 3 times z plus 7. So if you know that it's times 3 times z plus 7, how would you get rid of that 3? Well, it's 3 times z plus 7. It's 3 times this whole quantity. So if we're going to isolate this stuff, how do we get rid of a 3 times it? I might show you. Okay, let's follow through. So there's 2 ways you could do it, and I'll show you kind of those steps first. So it's called a distributive property. So if what I can do is I could distribute this 3 through the whole thing. So you were definitely tying into, oh, that's 3 times 7. That's part of it. That's correct. But it's also 3 times z. So if I'm going to distribute, what I get is 3 times z is 21. I'm sorry, excuse me. 3 times z is 3z, and 3 times a positive 7 is a positive 21, equals 21. So now this problem looks just like the problems we just did. So what's our next step now? Nice. Subtract the 21 from both sides, and what we get is 3z. Nice. So yeah, you divide it by 3, like you said, which gives us z equals 0. Perfect. You're absolutely right. Now, let's check. I'm going to show you a different way to do this one. So that's why I put this big green line down the middle. I want to show you a different way. If we have the exact same problem, a different way to solve it. And whichever one of these ways works for you is fine. If one of these ways doesn't make any sense, just cross it out. So this is 3 times this whole quantity, right? Like we talked about on the other side. 3 times z and 3 times 7. So what I can do as my first step, if I want to get rid of it, is what if I just divide this whole thing by 3? Well, I would divide both sides by 3. So I get rid of that 3 because it cancels out. And what I'm left with is z plus 7 equals 21 divided by 3 is 7. And then what's my last step? Nice. Subtract the 7 on both sides. Perfect. So both ways came up with the same answer. You just use whatever way makes more sense. All right. Ooh, we got, what are we on, 12? Okay. Are you done with that work? Can I erase that one? Okay. Number 12, negative 4 z minus 12 equals 42. Sure. Yeah, well, you could still, if so, there's the two ways we solved the last one. So if you want to do this one by distributive, yes, you would multiply both of them. You would multiply both of them by negative 4. So yes, the negative would stay with the 4. You would carry the negative into each of those. So let's do it that way. What's negative 4 times z? Perfect. We don't know what z is. In fact, that's what we're trying to solve. So it'd be negative 4z. Nice. A negative times negative is a positive. 4 times 12 is 48. Very good. So we have negative 4z plus 48 equals 42. What now? Nice. Minus the 48 on both sides. Subtract the 48 from 48 and from 42. Negative 4z equals negative 6. Not add it. It's a negative 4 times z. We would divide it since it's, yeah, exactly. So because there is a negative, what do we want to divide it by? We'll, exactly, because we want to take the negative with it so that the z is positive. So negative 4, negative 4. What's negative 6 divided by negative 4? Nope. Nope. You're absolutely right. Negative and a negative equals a positive. And then 6 divided by 4 equals, solid. Nice work, Cody. Very nice work. All right, you got all that work written down? You're good? Excellent. Okay, number 13. $33 equals 12R minus 3 times 9 minus R. It's the same exact thing, but you're right. It's written where our variables are on the right and our numbers on the left. But yes, it's the exact same thing. It's totally okay. That's perfect. If it's not, if that doesn't work for you, by all means, rewrite it so it works. Yep. Whoa, whoa, whoa. Where'd you get the 6? Oh, you have to multiply. So this has to be multiplied through the parentheses because it's attached because there's no operation right here. It means it's multiplication. So I have to multiply the -3. I have to multiply it times the 9. And then I have to multiply the -3 times the -r. Yeah, I'm sorry. Nice. -3 times a +9 is -27. And now, oh, nope, you got to do the -3 times the -r now. Well, it's a positive because it's a negative and a negative. So you get +3r. Excellent. Absolutely. Okay. How do I pause this?